Putila Shalini Emily binti Rosli.
I am Isa.
And my name is Nur Azrini.
In this video, we will explain and guide you about our topic, which is predictable. So, let's begin our exploration. First, let me introduce to you guys about predictable. So, predictable is a systematic arrangement of all non-chemical properties recognized based on their atomic number and electron configuration and recurring chemical properties. Let's move to the next part, which is organization in row and column. As you move from left to right, the atomic number will increase and the element generally will change from metal to non-metal. So, there is 18 groups in predictable. Elements in the same group have similar chemical properties because they have same number of valence electrons and they have similar reactivity patterns. So, let's move to the next part. Predictable has divided into 4 blocks, which is S block, B block, D block, and lastly F block. For S block, the group is 1, 2, 2 and helium. For B block, the group is 13 to 18. For D block, the group is transition metal, which is group 3 to 12. And lastly, for F block, the group is lanthanides and actinides. The next explanation is about metal, non-metal, and metal rock. Metal found on the left side and the center of predictable. They are a good conductor electricity. Non-metal are located at the right side of predictable and have a variety of properties, with a bad conductor. And lastly is metalloids. They are found along a zigzag line between metal and non-metal. Metalloids have both of properties. Predictable have special categories, which is alkaline metal, group 1, alkaline earth metal, group 2, transition metal, group 3 to 12, halogen group at 17, noble gases, group 18, and the last 2 group is lanthanides and actinides. And last part is about atomic number and symbol. Each element was identified by atomic number and chemical symbol.
And in this topic, we are going to learn about atomic structure and its property. What is atomic structure? Atomic structure refers to an arrangement of subatom particles, which is proton, neutrons, and electrons within an atom. Proton, a positively charged particles found in an atom. The number of protons determines the atomic number and identity of an element. Neutron, a neutral particles found in a nucleus. Neutron, along with protons, contribute to the atom's mass. And lastly, electrons, a negatively charged particles found in the regions outside the nucleus known as electron shell or orbital shells. Electrons are arranged in energy levels around the nucleus. On the other hand, the number of electrons in a neutral atom is equal to the number of protons, maintaining electrical neutrality. And the next thing we are going to learn is about arrangement of electrons. Electrons are organized into electron shell or energy level around the nucleus. And also, each shell can hold a specific amount of number of electrons. In this picture, we can see that the first shell can hold up onto 2 electrons. Next, the second shell can hold up onto 8 electrons. Lastly, the third shell can hold up onto 18 electrons and so on. Electrons fill the shell with an increasing energy level, with the lowest energy filling up the first. Next thing, we are going to learn about atomic number and mass number. As we can see from this example, the letter Z is atomic number, the letter E as the element symbol, and under it is the element names, and A as the mass itself. The next thing we are going to learn is about atomic mass. The atomic mass is the weight, average mass of an atom, taking into account of both protons and neutrons. It is typically expressed in atomic mass unit. It is also important to know that the atomic mass is often close to the atomic mass number, but it may differ because of the presence of isotopes. Previously, as we were talking about atomic mass, we encountered isotopes. And if you're wondering what isotope is, isotopes are atoms with the same element, which is the same number of protons, but with a different number of neutrons, resulting in different atomic masses. Speaking of stability, what is stability? Stability is atom that tends to have the most stable when the outer electron shell is full. For an example, it is noble gases. For an example, let's take a look at one of the elements from the noble gases from the periodic table. These argon elements are chemically inert when they have a full electron shells and in a stable state. This is different compared to another element where the atom of other elements may gain, lose, or even share electrons to reach a stable electron configurations. We are going to learn about electron configurations. Electron configurations refer to arrangement of electrons in atoms, electron share, or orbital. This configurations determines how the atoms will react chemically and even know the positions of the atoms in the periodic table. Each energy level can hold a certain number of electrons, which determines by the formula 2n to the power of 2, which n refers to the energy level's number. The energy level consists of a different sub-level that are labeled as S, P, D, and F. The number of sub-level increases with energy level. For an example, the first shells have S sub-level. The second shells have S and P sub-level. The third shell have S, P, and D sub-level, while the fourth one has S, P, D, and F sub-levels. The next thing we are going to learn is about electronegativity. Electronegativity is a tendency for an atom to pull electron in a chemical bond. Atoms with higher electronegativity tend to pull electron closer to the bond. Electronegativity increases across a period and decreases down a group in the periodic table. Next is atomic radius. Atomic radius is a distance from the nucleus to the outermost. It generally decreases across the period due to increasing nuclear charges, which means protons attract more electrons and increase down a group because of additional electron shells. Last but not least is ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom in its gaseous state. I'm gonna talk about periodic charts. Let's talk about atomic radius. What is atomic radius?
atomic radius is the radius of an atom, which is the distance between the nucleus and the edge of the atom. As you go down a group, the atomic radius keep getting bigger and bigger and bigger. For example, natrium have bigger atomic radius than lithium, but lithium have bigger atomic radius than hydrogen. This is because of hydrogen only have one electron shell. So, atomic radius increases down a group. Not only that, when the atomic radius trend across appear from left to the right, the atomic radius keep getting smaller and smaller. Next, I'm going to talk about application of periodic table predicting chemical properties and reactivity. Chemical properties are the characteristics of matter that can be observed when a substance undergoes a chemical reaction, while reactivity is a chemical property that describes how a substance reacts with other substances. There is 9 chemical properties such as toxicity, oxidation state, heat of combustion, chemical stability, flammability, coordination number, reactivity, possible chemical bonds, and the last one, enthalpy of formation. For example, potassium and water. Potassium is highly reactive with water, forming potassium hydroxide and hydrogen gas. Not only that, chlorine and fluorine. Chlorine and fluorine have a different atom structure, so chlorine is less reactive than fluorine.
That's all from us. Thank you everyone.